All right, so in this video, we're going to pick up where we left off. We're going to continue looking at problems off the more on the worksheet for section 5.7. All right, so let's think about this question. Okay, this is number 11. So these are the questions where we're actually looking at composition, and we're being asked to find the cosecant of the tan inverse of square root of 3 over 3. So you can use a unit circle, or you can think about special right triangles, whichever works best for you. Whenever I see square root of 3, I know it's related to a 30, 60, 90 degree triangle. And here would be the ratios of the sides of that. And how it became square root of 3 over 3 would be by looking at the tangent of 30 degrees, opposite over adjacent, and then rationalizing that. So that would be square root of 3 over 3, okay? All right, so I can think about it that way. Remember that this right here is the angle in the range from negative pi over 2 to pi over 2, whose tangent is square root of 3 over 3. So we now know it's related to the 30 degree angle. This is a positive value, so we are going to be in the first quadrant. So remember that negative square root of 2 over 2 to square root of 2 over 2 means quadrant 1 or 4. And then I just need to remember that 30 degrees is really pi over 6. Okay, so the tangent of pi over 6 would be square root of 3 over 3. And so, oh, actually, I didn't need to go through that route. I was just getting carried away. So I now know this is a pi over 6 or 30 degree angle, and I could wind up doing the cosecant of it by thinking about the cosecant of 30. And cosecant is related to sine. Okay, so instead of opposite over hypotenuse, it's hypotenuse over opposite. So it would be equal to 2. All right, but in reality, I think they don't mean for you to go through all of that. What I should have done is thought about the quadrant I would be in would be the first quadrant. Square root of 3 over 3 would be opposite, okay, over adjacent. It would be okay to write it that way. Find the other side. Okay, so if I found the third side, that would be square root of 3 squared plus 3 squared equals that missing side. So that would be 3 plus 9, which is 12. So c squared would be 12. So c would be the square root of 12. Okay, positive square root of 12. And that is 4 times 3. So that would be 2 square root of 3. Okay. All right, and then 2 square root of 3. Okay, and then to do cosecant, I should be thinking about how that's related to sine. So sine would be opposite over hypotenuse. So cosecant should be hypotenuse over opposite. And so it would be 2 square root of 3. Let me write it down here. So it would be 2 square root of 3 over the square root of 3, and that reduces to be 2. So that's another way to get it. So I wound up doing the right triangle approach. I like right triangle approach. And since it was in the first quadrant, that worked just fine to be thinking of it that way. But you also could think of it the way we were doing the other, where we actually thought about what quadrant we're in and we drew the picture. You really never needed to know the angle itself. You just needed to think about the definition for cosecant, okay? All right, so let's go ahead and look at number 12. Okay, 12 is cotangent of the sine inverse of square root of 2 over 2. Okay, so even though I don't need to know what the angle is, I could think it through that way, but they actually want us to use a sketch. So remember, this is going to be the angle in the first or fourth quadrant whose sine turns out to be square root of 2 over 2. Whose sine is square root of 2 over 2. Okay, so that's a positive value, so I know it's going to be in the first quadrant. Opposite over hypotenuse would be the sine. So there's my angle. It'd be square root of 2 over 2. Okay. I could use the Pythagorean theorem to get the other side. So that would be 2 plus a squared equals 4. A squared would equal 2. And see how a turns out to equal the square root of 2 as well right here? Okay. All right, now I need cotangent. So I know tangent was opposite over adjacent, so cotangent is adjacent over opposite. So it's square root of 2 over square root of 2, still 1. Okay, and that would be your final answer. So that would be using a sketch to do it. Now you could have been thinking through the right triangle approach. You know, you can't always get the value of this angle, but here, square root of 2 over 2, that should have triggered for you that this is really a 45-degree angle. Okay. And then you could think about the cotangent of a 45-degree angle. And you could go back to your unit circle where you have square root of 2 over 2 for both. And you could think about cotangent being the x divided by the y. And that's another way to see that it would equal 1. So making those connections, that's a good thing. I just don't want you just typing it into your calculator. All right, now here it says, find the exact value of the expression if possible. Do not use a calculator, okay? So let's see what happens on these. So here we have cosine and then cosine inverse of 0.5. All right, now normally you would think that cosine and cosine inverse would undo each other, and that's mostly true. The only issue is with the restriction we had to make in order to create a function that was an inverse. So normally they undo each other, so we're expecting the answer to be 0.5, but you have to just be a little bit careful about this. So this is the angle in the first or second quadrant whose cosine is 0.5. Okay, so when you're thinking about that, you know you're in the first quadrant because it's a positive number. Okay, so you're here in the first quadrant. This is the angle we're talking about. Okay, and we can write that as a 1/2 and do a sketch like we did before. Right, so we can do a sketch like we did before and think about cosine would be adjacent over hypotenuse. We could find the missing piece. So that would be positive or negative square root of 3, but we know we're talking about positive square root of 3. Okay. We don't need to know what the angle is. We just need to know now the cosine of this angle, and the cosine of this angle would be 1/2. So that would be our answer. Okay. All right. It's not always going to turn out to just cancel each other out like that. So you have to be careful. All right. Let's look at 14. Here we got cosine inverse of the cosine of negative pi over 6. Okay. All right. All right, so let's think about this. So negative pi over 6, that would be this way, pi over 6. Okay, so you can go to your unit circle, and you know that's also a 30-degree angle, but in the negative direction. So you can go back to your unit circle and think about where you would be. This right here would be negative pi over 6. So on the unit circle, you see the square root of 3 over 2 and the negative 1/2. Okay, so let me just remind you where we're at. We're right here. This was the negative pi over 6. That was square root of 3 over 2 with a negative 1/2. Okay, so the cosine of negative pi over 6 would be square root of 3 over 2. Okay, now I need to do cosine inverse of that. Here's where you got to be careful. Okay, because cosine inverse needs to be an angle in the first or second quadrants whose cosine is square root of 3 over 2. Okay, so we need an angle in the first or second quadrant that has the same cosine. We can't say it's negative pi over 6 because that's in the fourth quadrant and it needs to be in the first or the second quadrants. Okay, so if you look back at your unit circle, you'll see that right here you have an angle and the cosine, and the cosine of this angle would be square root of 3 over 2. It's just the positive pi over 6. So this turns out to be pi over 6, not negative pi over 6. You see how you had to watch out about that? About the sign of it? Okay. Let me see if I can get that back where it's supposed to be. If I move it too quick, it gets... Here we go. Let me see if I can back it up just a tad. All right, that's about as good as I can get it. Okay, let's see if I could look at number 15 with you. Okay, all right, with number 15, I'm doing cosine inverse of the cosine of 7 pi over 6. So let's think about 7 pi over 6. So first off, remember, if you got a 6 in the denominator, you should think about this thing being split into 6 pieces so you can count it. That's 1, 2, 3, 4, 5, 6. This would be 7 pi over 6 right here. Okay? All right, so if I'm trying to do this problem, I'm wanting the cosine of 7 pi over 6. So you can look at your unit circle, and you can see on the unit circle what you would have there, okay? And so you can go back to the unit circle and look. You could also, if you're comfortable with all those reference triangles we did before, you could think about it that way. See, this would have the same values as pi over 6, except for you might have to put negatives on things. This would be the negative of what you would have had over here at pi over 6. So if you already know pi over 6 is square root of 3 over 2 and 1/2, then you know this is negative square root of 3 over 2 and a negative 1/2. Okay? All right, so I know the cosine of 7 pi over 6. I can put in the value for that. It would be negative square root of 3 over 2. But when I try to turn around and do the cosine inverse of that value, this is now going to be an angle in the first or second quadrants with a cosine of negative square root of 3 over 2. So I still need a negative cosine. I have to be in the first or second quadrant, so I have to be in the second quadrant. So one of the things that was hard on one of the tests was the idea of a reference angle, but here's where it really comes back to benefit you. So like when I was trying to do the cosine of 7 pi over 6, I thought about it in terms of a reference angle. I knew it was going to have the same number part as the cosine of pi over 6. I just needed to have a negative on it. But now when I'm doing this and I need the cosine inverse of negative square root of 3 over 2, I know that here's another angle that has that same reference angle. And so I know this one right here has that same reference angle and also has a cosine that would be negative. So it needs to be this one right here. And that would be 1, 2, 3, 4, 5 pi over 6. So the answer to this should be 5 pi over 6. Okay. All right, got a couple more. Let's continue. These are hard, so that's why we're working through a lot of them. All right, and it's harder than it needs to be because if you hadn't really worked through reference angles, it makes it a little harder to think about. Okay, here I'm trying to do the inverse tangent of the tangent of 3 pi over 5. So that means I have to cut this into 5 pieces. So I do have to go a little over halfway to get to it. Okay, 5 is kind of a hard division to make. I don't know that I can make it look right. 1, 2, 3, 4, 5. Okay, so about right here. Okay, and so when I do the tangent of that, see, I don't have a unit circle that I can use. You know, I don't want to just use a calculator. So let's think about this. So the tangent of that, it's in the second quadrant, right? It's something I could try to figure out. Okay, here's the deal. I don't really need to figure out the answer to that. I just need to know tan inverse of that. Okay, so here's what you should be thinking. Tan inverse should be the angle in, and remember it's the first or the fourth quadrant, with a tangent equaling the tangent of 3 pi over 5. So I need an angle in the first or fourth quadrant that would have the same tangent as this angle, okay? So that means it would have to have the same reference angle. And remember, in this quadrant, the coordinates are negative, positive. So tangent is negative in that quadrant. So I need a negative tangent. I need a location of an angle that would have the same reference angle as this one. Okay. And so when you think about it, you've got one here. Okay. You've got one here, and you've got one here. All 4 of those have the same reference angle. Okay. So what I need is the one that would have a negative tangent. So I need this guy right here. All right. And so what I need to report is this. Okay. So you got to be careful here. So if this right here is 3 pi over 5, then the reference angle is 2 pi over 5. Okay. See that? So if this is 3 pi over 5, the remaining piece here would be 2 pi over 5. And your reference angle is always that angle between the terminal side and the x-axis. So this right here would be negative 2 pi over 5. So the answer to this should be, let me write it down here. So tan inverse of the tangent of 3 pi over 5 is going to equal negative 2 pi over 5. All right, you got to really think about these. All right, let's look at 17. It's the last one of this type. Okay, sine 4 pi over 7. I hate the ones that are like 5s and 7s, but that's why they give them to us. All right, so here, what I think about is how 4 pi over 7 is past halfway, because 3.5 would have been halfway. So I'm trying to imagine this cut into 7 pieces. 4 pi over 7 would be a little past halfway. Okay, got to get 7 pieces. And so that would have to be 5, 6, maybe something like that. So I need it to be 1, 2, 3, 4, 5, 6, 7 there. All right, now, so 4 pi over 7, let me put it in red, would be about right here. Okay, that's this angle. All right, now let's consider the reference angle. This one here. See how that means the reference angle would be 3 pi over 7. Okay. So 4 pi over 7 is here. The reference angle is 3 pi over 7. Okay. So 3 pi over 7 in all quadrants is what I'm trying to draw. I want this to be right there and this right there. Want all of those amounts to be 3 pi over 7. It's hard for me to draw that though. Okay. All right, so I need this. This is an angle in the first or fourth with a sine equal to the sine of 4 pi over 7. All right, so when you're looking at 4 pi over 7, the sine value is positive. Do you see that? This would be positive. So you can't be in the fourth quadrant. You have to be in the first quadrant. So you need an angle that has the same sine as that one. It would have to be the angle in the first quadrant. And so that means it would have to be 3 pi, 3 pi over 7 for your final answer. It would have to be the angle here that would have the same reference angle as that one. Have to be in the first quadrant. So it's 3 pi over 7. Okay. All right, now there's 3 more on the end of the worksheet that has you use a right triangle to write the expression as an algebraic expression. Assume that x is positive and in the domain of the given inverse trigonometric function. Okay, so let's look at that. So 18. I'll do a quick video on, no, I'll do it here. So on 18, I'm doing cosine, sine inverse of x. Okay, so I'm thinking about that as being an angle. Okay. All right, and so I'm assuming that x is somewhere in the, is positive and in the domain. So it has to be in the first quadrant because it tells me in the directions x is positive and it's in the domain. And I know that this has to be in the first or fourth. And if x is positive, I have to be in the first. Okay. So this is a value. And so I know the sine of this angle here turned out to be x. So I can put an x there with a 1 there so that I get the sine to be x. That means I can use the Pythagorean theorem to get this other spot right here. Okay. All right, so this would mean that x squared plus whatever that is has to equal 1 squared. So a squared would have to equal 1 minus x squared. So a would have to equal the square root of 1 minus x squared. Okay. And then I would think about that right here, 1 minus square root of 1 minus x squared. Now I need the cosine. So I'm looking at that triangle. Cosine is adjacent over hypotenuse. And that would just be the square root of 1 minus x squared. Okay. All right. That's how you do all of these. So let's take a look. These are a little easier than what we were doing earlier. So we have sine of the tan inverse of x. Okay. So this right here is the value. And tan inverse that x is positive. Tan inverse has to be in the first or fourth. Okay, since x has to be positive, it has to be in the first. So I'm going to draw it in the first. So I basically get that same picture as before. So let's go ahead and get that 1 minus x squared on there. This time, though, I want the sine. Oh, no, let me back up. It's not the same. It does have the x involved, but I wasn't thinking right. This is tangent this time. So I know the tangent of this angle has to be x. So that means this needs to be x, but this would be 1, opposite over adjacent, and I need to find that piece. So that would be x squared plus 1 squared equals the side I need. So c squared would equal x squared plus 1. So it would equal positive or negative square root of x squared plus 1. But of course, it'd be the positive one since this is a triangle, x squared plus 1. All right, so now I need the sine of that. So I'm going to do opposite over the hypotenuse, and I'm going to rationalize it. So it looks really messy. It's not hard, but it is a little messy. And I get an x squared plus 1 in the denominator. All right, and then one more, and then it'd be good to go right in and start working some of these on your own in the homework. All right, so the last one is tan of the secant inverse of square root of x squared plus 9 over x. Okay. All right, so let's think about that. All right, so this is positive, and that's positive. So this secant is positive, and secant and cosine are related. So we're looking for something in the first or the second quadrant. So again, it's going to wind up being in the first quadrant. So I'm going to draw my angle in the first quadrant. Here it is. This is my angle. Okay. What I'm being given is the secant. So if the secant of some angle equals this, then you know the cosine of the angle would have been that. Okay, and cosine is adjacent over hypotenuse. So we need to know this side right here. Okay, so we're going to find b. So we know x squared plus b squared would equal the square root of x squared plus 9 squared. So x squared plus b squared equals just x squared plus 9. The square root and square root and squaring undo each other. I'm going to subtract x squared from both sides, and I get that b squared equals 9, so it's positive or negative 3, so it has to be 3. Okay, so b equals 3. All right, all of that work now gets me ready to consider the tangent of that angle. Tangent is opposite over adjacent, so the answer to this would be 3 over x. And I'm done. Okay, so let me stop